and here I'll be discussing about my solution that I have prepared for my assignment. So the question that was assigned to me was to find the argon diagram of this number. The number is negative 14 to the power 1 by 3, and with the help of argon diagram I should be discussing about the values of this particular number. So before proceeding into my solution, I would like to discuss few things about argon diagram. As you can see in the figure that is displayed on your screen, the argon diagram is the modified form of the Cartesian coordinate plane, where the y-axis represents the imaginary part and the the x-axis represents the real part. So with the help of these facilities, we can represent complex number into the argon diagram. So here also I'll be representing this number into the argon diagram. As an argon diagram is a graphical representation of complex number where the x-axis represents the real part of the complex number and the y-axis represents the imaginary part of the complex number. In the figure also you can see uh, a point z is plotted over here and the value of z is x plus iy. So the x comes under the real part and the I times y comes under the imaginary part. So I times y is represented over here and x is represented over here. And as you can see, it looks like a vector and the angle that is made by this particular vector is considered to be theta, and the distance from the origin to the point z is considered to be r. So this was about my introduction about the argon diagram. Now let us start. How can we solve the complex variable negative 14 to the power 1 by 3. So first of all, we will compare this variable with the standard form of the complex number. So if we compare it, then we can get the value of x as negative 14 and the value of y as 0. And again, we can write this thing into the polar coordinate form where the value of x is equals to r times cos theta and the value of y is equals to r times sin theta. So now we have equation 2 and 3. So from equation 2 and 3, we can put the value of x and reformulate this equation into equation 4 and equation 5. So after we'll get equation 4 and 5, we'll be squaring these equations and we'll be adding it. So after squaring and adding, the final result of r is equals to 40. Now dividing equation 5 by 4, we can get tan theta is equals to y divided by x, and the result will be negative 0, and we can write the value of theta as pi. Then the complex number z is given as z is equals to r cos theta plus I sin theta, and the value of r is substituted as 14. So we have already calculated the value of r here from equation 4 and 5. So 14 times cos pi plus I sin pi. And again, we can rewrite this equation as 14 times e to the power pi. So now we know that e to the power I 2m pi is equals to 1. And with the help of this value, we can also write z is equals to 14 to the power 14 times e to the power pi. So if the value of 1 is equals to exponential to the power I 2m pi, then we can add 1 in this here in this line, and we can rewrite this equation as 14 times exponential to the power I times pi plus 2m pi. Now, after getting this one, we'll be using de Moivre's theorem, where if one part of the equation is reduced, one part of the powers of the variable is reduced, then all the power here is reduced accordingly. So if the power of z is 1 divided by 3, then we should be writing the power of 14 also as 1 divided by 3, and the power of Euler's numbers as also 1 divided by 3. So the final result of z to the power 1 by 3 is displayed over here. So as we know, the cube roots have three distinctive values. So to find those three distinct values, we'll be putting the value of m as 0, 1, and 2. So if you put the value of m as 0, then we'll get the first result as a is equals to 14 to the power 1 by 3 times half plus I sine square root over 3 divided by 2. So this is our first result. And again, if we put the value of m as 1, then we can get b, that means that is the second result of the same question. And b is equals to negative 14 to the power 1 by 3. And finally, we will be putting the value of m that is equals to 2. And if the value of m is equals to 2, then the third result, then the third answer that we'll get here is c is equals to 14 to the power 1 by 3 times half minus I square root over 3 divided by 2. So here we have computed three different results of the given question. So as you can see here, there are three different values a, b, and c. Now finally, we'll be putting or we'll be plotting those values in an Argand diagram. So as you can see, the value of A is positive and we have the complex part also over here. So the value of A lies in the first quadrant. Similarly, for the value of B, it is perfectly real number and it is negative in its sign. So we have kept the value of B in the x axis here over here, and for the value of c we have kept it in the fourth quadrant because we have negative sign over here. So this is our result. Thank you.